Hey folks, welcome back and thank you again for joining us on AWS On Air. My name is Adrian San Miguel. I'm a partner enterprise architect here at AWS, and as usual, joined by the good friend Todd. Say hey, Todd.
Hey everybody, I'm Todd Fortier. I'm a senior solutions architect here at AWS, where I focus on developing solutions for the AWS Solutions Library. And Adrian, today we've got a really cool one, something that's kind of near and dear to my heart, something that I think about outside of work, but also inside of work whenever I see it happening. Today we're going to be talking to Coastal Carbon and how they are leveraging AWS to train AI models for ocean restoration and climate action. So this is a cool segment. What you think? What do you have you are you do you are you familiar with like some of the work that AWS is doing to restore the ocean?
A little bit, yeah. I understood that there's a little bit of a climate connection that has recently come up. I know we were doing some stuff with United Nations. I know there was a grant that was put together, but honestly, I'm not that well read up on it. I probably should, but at this point, I can't really help myself and control, the hours in the day.
Yeah, well, that's why we bring on experts onto this show to talk about this stuff. So should we bring on our expert and
Absolutely.
hey James, welcome to the
Oh
show.
yeah.
Boop, you just like that TV magic, and you're here. Hey, welcome to the show, James. Why don't we start off by first letting you introduce yourself, and then we'll jump into Coastal Carbon's work.
For sure. I'm James Lohman. I'm a founding engineer at Coastal Carbon. We work in AI and ocean restoration. We partnered with AWS and the UN to try and advance sea ocean health through AI and generative AI, and it's been an exciting ride for the past year.
Yeah, and I understand that you've done that specifically around kelp. Now, kelp is not something I was super familiar with. I knew it was of kelp; it was a seaweed. But funny story. I first heard of it at the Amazon office. There's this new uh, uh, smoothie place just underneath the building, and I went in there and I saw seaweed and kelp all over the menu, and I was like, "Wait, what? What are you, like people are eating?" So, yeah, this is like the new super power food that people are eating in their smoothies. So help us
Yeah.
understand, what is kelp exactly?
I mean, it's like that gross seaweed that covers beaches if you're on vacation, but
Okay.
on the climate side, it is like one of the fastest ways to absorb carbon out of the atmosphere, like out of any plants, better than bamboo, better than corn. It grows so fast. It's just sitting there in the ocean, and we see these beautiful kelp forests. If you've ever seen like an Apple screensaver, that's one of them with fish. It's just
Yeah.
biodiversity at its core. Happens in kelp forests for sure.
And so you can actually see this stuff from space.
That's right. That's exactly what we've been working on. Is that
Ah,
we can monitor kelp forests like regeneration, or in the case of farmers, if they're growing it, we can measure their biomass from space using satellites that everybody's using these days.
that's got to
Cool.
be pretty revolutionary. And I'll come out and say it, kind of groundbreaking, even though we're talking about the ocean. The bulk of my knowledge of kelp and seaweed is restricted to whatever is in a particular movie about a lost fish that may live in the sea anemone.
Yeah.
Uh, I think we can fill in the blanks on that one. But yeah, I spent a good deal of my time during the cold months fishing the bull drum run down on the coast of Texas. And yeah, if the grass isn't healthy, if we don't have a good coverage of seaweed, it's impossible to really do anything. So yeah, it is part and parcel. Very, very curious. You mentioned kind of two different things that really don't relate. You mentioned satellite and AI with kelp, but how does
Yeah.
that all come together with what you're doing?
Well, I mean, satellites are super cool cameras because like our eyes work in red, green, and blue. So all of our cameras and screens and everything seem to operate in red, green, and blue. But it's really not that big of a stretch to have like three different shades of green and go to the near infrared spectrum and see all kinds of different like extra spectral information. And that's why we chose to use AI, because the world has a lot more complexity than just sits on the surface with three colors only. So that stuff exists on satellites, and we leverage it to try and identify the right types of kelp, especially if they're like floating kelp or sugar kelps that they farm. And we can measure biomass. So biomass being just how much of it is there, and how fast is it growing.
Okay, I think I get it. So satellites are orbiting the Earth and they're taking pictures of our oceans constantly. And you need to distinguish between what is kelp and what isn't kelp. And that might be a little tricky for our eyes to be able to do this, but with the power of AI, we can now all of a sudden start to distinguish, okay, this is a biomass, it's kelp, it's this type, it's off this, it's this much, and you can calculate that really quickly.
That's right.
That's fascinating. So help me understand the carbon credit part of this, because we were just before the show, we were talking about carbon credits, and there's this marketplace for measuring how much carbon is being captured, and that's a way to kind of fund some of these initiatives. Help me understand what a carbon credit is and how this relates.
Yeah, I mean, the easiest way to think about it is that, plant growing is absorbing carbon dioxide out of the air. That's sort of been our history for a few million years, right? The fact that we're generating more carbon means that ideally, if we wanted to pull more of it out of the air, plants are a great way to do it because we can utilize a lot of stuff from the plants anyway. And that has shifted from being definitely stuff on land to, can we increase the plant mass in the oceans and coastal areas, especially since we've destroyed a lot of them as a species. Things like mangrove forests that are along the oceans, a lot got torn out because they make really great habitats to farm shrimp. And I mean, I'm not trying to shame anyone for eating shrimp by any means, but if you can return those coastal areas to being sort of the biodiverse versions that they were in some sort of meaningful way, then you have an opportunity to absorb a lot more carbon than we are currently. And the carbon credit system is that people who don't have a choice but to add carbon to the atmosphere, things like airlines, we all rely on it. Nobody's going to stop flying anywhere, but they want to be socially responsible. They don't want the Earth to be warming. And so they buy these carbon credits in addition to try and offset what they're doing. And we can route that through to kelp farmers.
Okay, so
this looks like, I think you're about to ask the same thing.
Yeah, I was just gonna say, so Coastal Carbon teamed up with the AWS Compute for Climate Fellowship Program in the UN to help develop using Amazon SageMaker Hyperpod to train these models. And you've got a demo to show us kind of what that ended up becoming. Should we bring your screen on and get to that demo?
Yeah. So this is sort of a public-facing thing we did in conjunction with a professor out of MIT to try and map kelp. So this is not something we sell, just something we sort of let the world sort of have a piece of. So we use the Sentinel-2 satellite and AI, and if I click on the map, it'll zoom in to a specific area here, the Channel Islands off the coast of California, and you can see a kelp forest. This is all identified by the AI, and this is only one specific month, but we offer temporal versions of this where you can sort of watch the kelp forest grow and shrink over the seasons, or if you're providing any kind of restoration, then there's lots of opportunity there to see if it's working, how fast is it coming back? So we can track this kelp growing. These are density fields, so like how much kelp there is at any given spot. We track it along most coasts. So if I zoom in on Vancouver here, wherever Tofino is, there's a lot of kelp off of there. There's these islands. We track it in Japan. It's just sort of a global thing for us at this moment, and that's what AWS and SageMaker and Hyperpod has allowed us to do this on a global scale without analytics.
Yeah, James, I love a good animated globe action in any demo, but I want to hear from our folks in the chat. Are you off a coast? Are you familiar with some of these kelp? Have you eaten kelp before, like I just recently did? Where are you in the world? And let us know if you're thinking about kelp or have interaction with it. But you're saying, so let me just get this straight. So the little green pixels that I'm seeing off of these coasts, that's the kelp that you're tracking. You're using AI, and it's identifying and coloring in the screen.
This is one species of kelp called bull kelp that happens to grow in these large forests off of California, off of the West Coast in general, and then some of it's in other parts of the world as well.
Bull kelp. And are you tracking other species of kelp as well?
Yeah, so we do that as a professional service. We track sugar kelp that's grown on long lines. There's other kinds of non-kelp seaweeds that we track as well. Again, it's sort of a paid service that we do is eelgrass or like different. That's our offerings to farmers is like, can we show you your biomass mapping? Can we use that to measure and offer you carbon credits, give you another revenue stream?
Yeah, absolutely.
Yeah.
I mean, even just the idea of, hey, let's stop using long lines for targeted species retrieval and harvesting. Maybe we can start using that same bit of equipment and teach you a new trick so that you can start farming for kelp and open up that other revenue stream. I gotta say, it's pretty ingenious. And we like to talk about Invent and Simplify at AWS. And yeah, this is really the definition of that. It's pretty cool.
Yeah, James, let's get a little bit into the tech. So we're talking about SageMaker HyperPod. And for our customers who might not know what SageMaker is, a collection of different AI and generative AI tooling, but with specifically within SageMaker, we have this thing called HyperPod, which allows us to speed up the training of AI models. How is Coastal Carbon using HyperPod to do that?
Yeah. So I mentioned earlier that there's this like extra information that exists in satellite images. Like a really great satellite might have 8 bands. An even better one could have 15. There's the hyperspectral ones that have thousands of spectral bands, meaning that they're different photographs, but they only focus in on a very narrow spectrum. And it's incredibly powerful. Like the pure math of it all is amazing. So like we see an RGB and our screens operate on 256 different versions of red, green, and blue. You multiply 256 by 256 by 256 and you get like 17 million possibilities. So our screens can show 17 million. If I take, because we in a satellite we have 16-bit information, so there's 65,000 possibilities for each band, and then if there's 8 of them, that's 65,000 or 65,000 8 times. We're talking about more atoms than there are in the known universe in terms of like a sheer just possibility of color differentiation. It's unmanageable quantities of data that haven't like I feel like we haven't seen the extent of where this stuff can go. What can we really see and how can we see it? And the fact that a company like SpaceX has sort of kicked the door down on cheap launches means that more and more and more of these satellites go up every month, and we're seeing more and more of the Earth than we've ever done before. So it's opened up this opportunity for us to be able to provide really, really interesting analytics tools on Earth observation in general. And I mean, we started with kelp, but we've even moved on. We track boats, we manage forests. We're looking at urban development. And the reason we can do all of that is because we developed our own foundational model that's able to operate on this incredibly huge quantity of data. And we wouldn't have been able to do that without the use of HyperPod.
Would it be possible to zoom back in and show the group or the viewers the different levels of density in just any one of these areas? It could be either representative of one particular species, or like, hey, this particular pot, there may be more nitrogen in the water, or whatever it may be, that be influencing the additional growth, or in some of these instances, it's just like a super localized hotspot. I can't imagine the volumes of tomes of data that are required to make that happen.
Yeah, so this is a pretty static map. This isn't a temporal version that we have, but in here, what you're seeing is, I believe it's August of this year, just off of one of the Channel Islands. And this area is sort of great for growing kelp. The reason being is that nobody's come and messed with it. There's other like super interesting things that like there's a whole biodiversity that has to match up. Like sea urchins tend to eat kelp and destroy it, but then you get sea otters that eat sea urchins. So you have to have this full balance. And if any one of them goes out of whack, then it sort of falls apart in that area, and they have to try and help fix it. But what you see here are very dense clumps of these forests, and this is showing the density of the floating portion of the kelp. So where you see the darkest greens here in the middle, that's just thick kelp you can see. What we have in behind is a base map, but if I zoom in really close here, you can actually sort of see leaves of other kelp. It won't show up in our AI because we're using a satellite image to create these maps of where the kelp are, and then we're overlaying it on Mapbox, which is a partner that does the actual base map in behind to make it look cool.
Very cool.
Very cool. So you're talking about satellite images. We're talking about petabytes of data. What you described before was kind of blowing my mind. I don't even know if I could wrap my head around it. And so in order to train these models, you need a massive amount of computational power. And you're saying this is what SageMaker HyperPod is giving you to be able to feed all of this data. And so I guess my question is, this data is changing, right? I mean, I imagine it's regularly changing. How often are you receiving updated data? How often are you updating this map? What does that process look like?
This map in particular is usually updated once a quarter. But this is, again, the public facing free tool. And it all comes down to what people want when we are actually monitoring for them. So in terms of like monitoring a kelp farm, we might measure weekly or daily. I mean, that gets down to like how many clouds are in the sky at any given time. But yeah, I mean, the options are increasing all the time. And again, that's thanks to a company like SpaceX that is able to launch 300 extra satellites every month.
Yeah, let's get into that a little bit. Like, what are the source? My understanding of satellite imagery, just from some of the work I've done in agriculture, and my wife and I happen to be starting a farm ourselves. So, carbon capture is something we're thinking about constantly. We want to kind of use regenerative farming techniques to be able to capture that carbon, do farming in a responsible way. And I've seen the same sort of different sources of satellite images used to track agricultural, particularly crop loss or weather patterns. What are some of the sources of satellite imagery? Is there different types of satellite imagery, and what are you using to do this work?
Yeah. So yeah, there's a lot of different satellites. Some are free, some are paid. The free ones sort of fall under like the NASA or the European Space Agency. So NASA and NOAA operate, or I think it's actually the USGS operates Landsat, and this one is low resolution in so much that it's like 30 meters by 30 meters per pixel, but it's been operating for 40 years. So that temporal data is unbelievable. Like you can track changes, and they've made sure they've kept a version of Landsat up for that entire period. The European Space Agency operates a fleet of satellites called Sentinel, and Sentinel-2 in particular is optical, and it has a 10 meter by 10 meter resolution. And that's what we use here on Kelp Sentinel. That's the name.
Nice.
Yeah, to try and like help map it and keep it up to date, because it revisits any spot on the Earth approximately once every 5 days.
Wow. I mean, there's certainly art and science married into this, and given the volumes of data, the expertise that's required to build, manage, maintain, feed, and all that of a foundational model you build yourself, surely you have to have PhD level AI and ML experts in well trained in the discipline. How has leveraging AWS's infrastructure and these different technologies helped bridge that gap between extremely hyper focused expertise and then helpful effectively marrying these two disciplines in your day-to-day work?
Oh, it's pretty funny you mentioned that, because like we all were PhD students. It's how a lot of us had met originally before we sort of got into the startup game. And in any PhD, you have to fight for resources. Nobody gives you any compute for free, right? So we're kind of used to just like trying to do everything ourselves in the most scrappy way. And then we got introduced to the AWS ecosystem. It's like blown mind. Like, oh, this can be not only easy but scalable. We've been associated with a team at AWS who's been helping us almost, it feels like nonstop for 10 months now, getting up to date on how we use SageMaker, and then specifically HyperPod to train the large models, how it can hot swap in nodes when they die on super large training job, which is like incredible. Like for us, we would have stopped and worried that everything was going to die. But
maybe a little bit of crying in the background. Yeah.
Well, James, I've got an idea for your next. I need a chicken sentinel. I'm managing chickens that are constantly getting out, because like I said, we're trying to use regenerative practices, so we're moving them with fencing, and we're constantly like chasing chickens around the farm and trying to figure out. And I could almost imagine this imaging system to show me density of chickens and then show me where I've got some strings. So if you could get to work on building a chicken sentinel, we'd really appreciate that. Cool, James. So we've got just a few seconds left. I want to make sure we've shown everything in your demo, and then I also want to give our audience a place to go. Where can they go to learn more about Kelp Sentinel or blue carbon credits, or just the work that you're doing generally?
Yeah, absolutely. Our website is coastalcarbon.ai. Kelp Sentinel is hosted at kelpsentinel.coastalcarbon.ai, and we would love to hear from anybody, especially if you're working in remote sensing, satellite operations, and machine learning.
Very cool. Hey, James, well, thanks for coming on the show and showing us some of the work that you're doing, and good luck tracking the world's kelp.
Thank you. Great to meet you guys.
Likewise. Thanks.